Oh, wait, oh, sorry. Let me get my thing going. Okay, so here we have a system of equations. You know, that is something that could come up on the exam, the final, that is. And really the two ways you can really use to solve it, I guess for an exam, so to say, with me, is elimination or substitution. I mean, you really technically could use graphing to solve it, but because this class is virtual, you know, online that is, I'm not going to ask you to solve it by using Desmos. You could use Desmos to check. That's really what I recommend you do, actually. Okay? That's what I strongly recommend you do. All right. But anyway, for this system, I'm going to show you first how to solve it using elimination and then using substitution. You only have to use the method I tell you to use on the exam. Okay? You know, if I tell you to use elimination, you have to use elimination. So, but anyway, here, remember the whole point with elimination, right, is we want to kill off a variable. You know, that's really what we want to do. Kill off a variable. Now, how can we do that? I mean, there's more than one way to do that. What I did was I decided to multiply the first equation by -4. Now, why is that? Well, then the coefficient of x here will become -2. And then you can add it to the second equation, right? And the x's will go away. So here, as you can see, we have, I multiplied both sides by -4, okay? You know, we distribute, as you can see, right? We distribute. And what we end up getting is -4 times 1/2 times x plus -4 times 2y equals -4 times 9. So we have -4 times 1/2 times x plus -4 times 2y equals -4 times 9. And so if you carry out these products, you get this, -2 times x, so you can see, plus -8 times y equals -36. So that's really sort of our new first equation. That's our new first equation, okay? Now, okay, so that's basically, in a sense, replacing this equation. Actually, no, I shouldn't say that. I'm sorry, I misspoke, I apologize. So we have this equation. Now we're going to add this to the second equation, right? When you add it to the second equation, these x's are gone, okay? These x's are gone. So we get -8y, right? So when we add, the x's are gone. We have -8y plus -3y, which is -11y. Okay? Here we have -36 plus 14 is -22. Okay, so from here, what do we get? We have -11y equals -22. Okay, so then we divide both. Again, we want to get y, right? So we get y all alone. So we divide both sides by -22, by -11. Doing so, we get y on the left, right? Because the -11s, let me draw it out. They cancel, you get y on the left equals -22 over -11. We get 2. Okay, that's what we get here. Y equals 2. Now, are you done with the problem? Are we done with the problem? No, we have y, yeah, but we need x. How do we get x? Well, 14 is 2x minus 3y, right? Which is 2x minus we replace, now we take one of the equations and we replace y with 2, okay? So I took the second equation and replaced y with 2. I could have done that with the first equation, except we have a fraction here. You know, it's a little bit easier, at least I think so, to work with the second in that case. So we replace y with 2, which is what we got, and we get 14 is 2x minus 3y, second equation, which is 2x minus 3 times 2, which is 2x minus 6. And so from here, we get 14 equals 2x minus 6. Now we have this equation to solve. So again, let me just say it again. Once we got y, we have to go back to the original system and replace y in one of the equations with what we got for y. So I chose the second equation and replaced y with 2. Again, you could have done the first equation, except there was a fraction there. So I replaced y with 2, and I get this equation. So we solve for x. So we have 2x minus 6 equals 14. I interchange both sides of the equation. Okay, we add 6 to both. Again, we want to solve for x, right? So we add 6 to both sides, and we get 2x equals 20. But we don't want 2x. We want x. How do we do that? How do we get that? We just divide by 2. Divide both sides by 2. We get x on the left equals 20 over 2, which is 10. Okay, so what's our solution then? Our solution then is 10, 2. This ordered pair. Okay. Are there any questions on that? Okay. Now that was one method. Let's also solve this using substitution. I'm not going to ask you to solve a system both ways. It's just that I like to show you how to solve it using both methods, because I don't know which method you would prefer to use. You know, but let's say we wanted to solve it by or I could tell you solve it by substitution. So in that case, you don't want to use elimination. So for substitution, right, we have 2x. So again, we want to somehow get x in terms of y, or y in terms of x, and then substitute. That's what we want to do. Okay, so what I did was from the first equation, right, we can eliminate that fraction as well. I can get x in terms of y, okay? So I get the 2y on the other side by subtracting. We have 9 minus 2y. So we have 1 over 2 times x equals 9 minus 2y. Okay, so wait, sorry, I went too fast. See what I did? I subtracted 2y from each side. And I get 1 over 2 times x equals 9 minus 2y. But again, we want to get x in terms of y. So what I can do is I can multiply both sides by 2. And when I do that, what happens? These 2's cancel. You get x all alone. And we distribute. So again, so that's what happens over here. So again, the 2's cancel, right? These 2's are gone. We get x on the left equals 2 times 9 minus 2 times 2y. So we get x equals 18 minus 4y. So that's what we get here. So we have x in terms of y. Again, was this the only thing you could have done? No. You could get y in terms of x, or you could use the second equation to get x in terms of y, or y in terms of x. You could do that. I mean, if you do everything correctly, you'll get the right answer. So we have x in terms of y. What do we do next? Well, we're going to take this and we're going to plug it in for x into the other equation. That's what we're going to do.